Now that is a very short video that talks about how to test whether a time series contains arch effects. The logic of testing for arch effects is straightforward. You simply look at the data to see whether there is evidence for autocorrelation in squared residuals. I therefore want to address two questions. First, as you likely start off with a time series, for example for returns, the question might come up where to get the residuals from. And second, why is it a good idea to test for autocorrelation in squared residuals and not just, for example, in the residuals themselves? So let's turn to the first question. And yes, indeed, you somehow have to come up with the time series of residuals. So maybe you've noticed that arch models are also called armor arch models. The armor in front highlights that the conditional expectation of a time series is modeled by an armor process, while the conditional variance is modeled by an arch parametrization. So long story short, you have to apply your favorite armor model to subtract from the time series that you look at the conditional mean. That way you end up with a time series of residuals. And yes, the time series of residuals will look different if you use a different armor model. It's therefore important that you model the conditional mean in the most precise way possible. Now let's address the second question. So let's remember what the word arch stands for. That is a short version for autocorrelated conditional heteroscedasticity. Therefore, testing for arch effects in residuals means you want to test whether there is evidence that time-varying second moments have an autocorrelation. So note that the mean of the residuals are zero by construction. That implies that the variance of the residual coincides with the second moment. While you don't observe the time series of second moments, you do observe a time series of squared residuals. Using squared residuals as a proxy for second moments might be crude, yet it's a useful approximation. And therefore testing whether there's autocorrelation in squared residuals is as close as it gets towards testing whether the variance of residuals shares an autocorrelation. Now there are two prominent tests for detecting arch effects in residuals. These are the Portmanteau test and the Lagrange multiplier test of Engel 1982. Both tests are equally reliable and work similarly. You can basically choose one of these two or run both. I will have a video on each of these tests.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.